Hi, welcome to a club presentation on Java where we'll be talking about string formatting and the basics of file I/O. My name is Aaron, and this is an episode of Obvious Java, episode 1.1. This arc contains three episodes, and at the end, we will be creating a capstone project where we will be applying what we learned in 1.1 and 1.2. If you'd like to get some materials to code along in this lesson, make sure to join our Discord channel at the link provided over here and then type in the code 32C8 in the search bar to search for the relevant materials. Let's get started. String formatting. Why does it matter? A lot of the times when you handle strings, you might want it to look a certain way when it's output. Maybe when it look pretty or organized, or maybe look a certain way that you want. And string formatting is one way to do it. Another reason why string formatting is important is because it helps present data coherently on the console. So let's say if you have a big file, a CSV file from Excel or something, where it's comma delimited, it's really hard to read these files when you open them in a text editor. But if you are able to make a program that can parse these data and then help help you visualize on what it's actually about, then it can actually allow you to visualize it much better. Project requirements. When you do projects in an academic environment, maybe you are doing a class project, or maybe you're doing a personal project or at work, you might want to present your data in a very coherent manner because good data is the best data to sell. And in 1.3, we will be doing something like this where we will be taking information from a file and then printing it out to make something really pretty. So let's look at strings in the meantime. This project assumes that you have absolutely no idea what Java is. You're fresh on a clean slate. Hang on. So let's start by creating a string. We want to give a string a name. So let's give it a name str1. Honestly, you can call it whatever you want, but I'll call it str1 equals to whatever I want a string to be. And then I will add a semicolon over here. Now, you will notice that it's red over here. Java is complaining that something is wrong. What's wrong? Because we didn't tell Java what str1 is supposed to be. Is it a string, a number, a double, a boolean? Java doesn't know. That's why it's complaining. So we will need to tell it what we want to do, and this is how you do it. String, 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 str1 equals quotation marks like this. Mind the capitalization here, it's quite important. If you don't do it, it will break. Let's start by running this program. You'll notice that pretty much nothing happens. It's pretty boring. So there is one line over here by the system, and then one blank line with process finish with exit code 0. This signifies that your program has finished running and there are no issues detected. Now, the single line here is created by the system, it's not created by us, but let's see how we can influence it. When I create a string and then give it something, let's say 1, 2, 3, 4, and then I run it, nothing really happens, even though we want it to print over here. In order to get it to print, we have to use a function called system.out.println, and then there's a parenthesis over here. Also, remember there's a capitalization over here. So we are telling the system to print something. It's going to ask us, what do you want me to print? Then we will say, I want you to print str1, which contains 2, 3, 4. So str1 like so. And then when I run it, you'll notice that there is actually something over here. Our 234. Now let's get rid of the 234 and just make an empty quotation mark over here. And you will notice that instead of printing one line, it actually prints two lines. Because an empty quotation mark will still take one line, and this is very important. Now, let's move on and add something to the quotation marks. We add a space, and then you will notice that while we still only have two lines, we have one dot over here, and that signifies that there is one space over here. Although it's really hard to see, you may notice that there is a gray dot over here, and this will signify a space character. Let's move on to one of the basic things in string formatting. We want to try tab, so we do a \t, then t. This actually prints out a tab, which can vary depending on your system. In mine, it will be four spaces. It's kind of hard to prove right now, but let's get to it in a second. In order to change how many spaces your tabs take, we can go to IntelliJ, your settings, then we will go to your editor, then we will do code style, Java, because that's what we're working in. And then you see a lot of tabs here. We will choose tabs and indents 4. So that's what we will be working with. In some cases, you may see people using 2, 6, 8, but 4 is the one that we'll be using today because it looks neat. And then we will just press OK. We actually change nothing. So one tab, 4 spaces. Now let's add another one and then see what's going to happen. You'll notice that there are two spaces here, two dashes, I mean, and each of the dashes 4 spaces long, 4 characters long, for a total of 8. You may think that a single tab may just add 4 spaces or whatever that your system is on, but in reality, it does not actually do something like that. Let's see what it actually does. String str2, let's make a new string, and I will create a new string right now with 6 spaces. 1, 2, 3, 4, 5, 6, and I'll put that over here. So we will print a second string right underneath here and try to make a guess on how wide this string will be. Some may say that it's 10 spaces because 6 plus 2 plus 4, sorry, 6 plus 4 makes 10, but it actually only creates 8 spaces, as we can see. Oops, we have to actually print it as well. System.out str2, like so. And we will print it like this. So you can see there's actually the first line here and the second line. And after the 6 spaces, we only have a tiny little dash, which is just 2 characters long. And you notice that it's actually the same length as the previous string. What gives? So a tab doesn't actually add 4 spaces every single time. What it does is it will add enough spaces to bring the length of your string to the nearest multiple of 4. So if you have 6 and you add a tab, it will give you 8. If you have 9 and you give it a tab, it will give you 12, and so on. Let's try something a bit different for backslashes. We will want to try something with n. So n means new line. What you can normally expect from a new line is basically to create a new line. We will know that initially we have one line from the system over here, and then one line from the quotation mark. The \n basically creates a new line, which you can see here. So 3 lines in total. That means if you add more new lines like this, let's say 5, we will have 1 from the quotation marks over here, and we have 5 over here. That gives us 6. And the system will just create one more uh, by itself. So we will have 7 blank lines. Let's see whether this is true. So we will highlight 1, 2, 3, 4, 5, 6, 7. And that is how you create new lines. Now let's move on to something a little bit different. I'm going to put 2 bars. You do string concatenation. 2 bars like that. Pretty simple, nothing too special about it. 2 bars, no extra space, no nothing. Exactly what it says. So if we want to combine 2 strings, we will just put 2 strings like so. And then Java complains. So you will need to put a plus here. So we will actually be concatenating 2 strings like this, as you can see. And when we run it, we will have 4 bars with no spacing. We can add spacing, but just to show my point, the spaces outside of the quotation marks has no effect on whatever that's it's been printed. So I can do a bunch of spaces here to prove the point. And you will notice that the output is exactly the same, like so. That means anything that's outside of the quotation marks have no bearing on the result. But it's good to have a space around the arithmetic operator like this because it's tidier. So if we really want to put a space, we will do something like this. We can put a space in the quotation mark. You can put it here or here. It doesn't matter. If you do it both, then you have 2 spaces. Alternatively, you can actually put an entirely new quotation mark here, a new string, and then you can put all the spaces you want in the world. And when we run it, you see a huge amount of spaces between the bars. Oops, pardon this. Some of you who have been in Python may know how to repeat a certain string. If you can just multiply it. Java's a little bit different, so let's see how we can do it. We will start with 2 bars like this, as we have done earlier. Then we will do this. We will get str1, which contains 2 bars to repeat itself. So, hey, str1, I'm talking to you. I'm going to ask you to do something. Dot. Then str1 has a lot of things that you can ask it to do. Then we will choose repeat with parentheses and a closing semicolon. So the purpose of this is to give an argument to the repeat. So string 1 will do repeat, and you ask us, how do you want it done? We want it done 3 times, like so. When we run it, you notice that there's actually no difference at all, even though you may expect more bars over here. The reason is this line actually has no issue. Java did read this line, it didn't forget anything. But the result that comes from evaluating this is not used at all. We didn't save it, we didn't use an equal sign to save it somewhere, we didn't print it, we did nothing to it. So whatever that's being evaluated here, Java will just throw it away and it's gone. That's it. To actually have an effect, we would try something like str1 equals str1 dot repeat equals 3. So we would say that the result of this has many bars. So str1 will now have many bars. 6 bars right now. Like so. You may think that repeat causes this to add another 3 sets of bars. But that's actually not the case, because if it is, we would have 8 bars. So what happened? Repeat doesn't actually add more bars. It just tells str1 to be 3 times more. So I want 3 copies of this. I want str1 to be 3 copies of this. I want str1 to be 6 copies of this, and so on. So as you can see, 2 times 3, we got 6 bars. Some of you who are already a little bit more ahead may find something more interesting and a better way to do it. But not better, maybe something a bit different. We can use int, idx. This is something that we will be learning tomorrow in the next class. So this is how it generally looks like. So str1 plus equals 2 bars, like so. Then when you run it, we will have a lot of bars, lots of them. But this is something that we will be discussing more tomorrow in better detail, so don't worry about it too much. Now let's try something a little bit different. Let's use some words. Apple plus pies, like so. You notice that when I print this, you will get apple pies, but with no spaces. So in order to make spaces, I will do it something like this: quotation marks, spaces inside, apple pies. So 3 strings: apple, a space, pies, apple pies, like so. You may wonder, what's the point of using quotation marks? Why is it so troublesome? And this is the reason why. Let's create a new string. String str2 equals r the delicious, like this. So if we want to complete the sentence, we would add string 2 to string 1, like so. And then we will get a very nice sentence. Excuse me. Apple pies are delicious. So you have noticed that str2 is not r delicious, it's the variable here which contains r delicious. So the moment you remove your quotation marks like so, Java will think that, oh, pies must be a variable, but I don't see you talking about pies earlier anywhere in the code. So Java freaks out, and when you run it, your program will crash because Java cannot find the symbol. What is pies? I have no idea what it is. So therefore, we use quotation marks for those that we want to print directly. Let's try something a bit different. We will look at padding. So there are many other ways of basic string formatting. We can do padding to the left or the right. We can do rounding, decimal places, significant figures, scientific. So a lot of these are from the math classes that you've been in. And if you're taking engineering classes, you might see significant figures and scientific notation a little bit more. We also have accounting format, prefix, suffix, date format, color, new lines, etc. These are only a few, but there are many ways you can format a string. So here's one way you can do it. A lot of students may do some searching online when they try to format a string, and then they find a solution and they think that it works and they paste it in their code. That's fine and all, but a lot of the times people don't really understand how this actually works. They just copy the code and they paste it. So in this presentation, we'll be looking to the string.format in detail, and by knowing what to do after seeing this video, you will be able to format your strings with better precision and to the way exactly that you want it with confidence. So to format a string, we will type this down, and then these 4 boxes represent the format inside here. So it's a bit overwhelming at first. Let's just remove everything and we start with a percentage and width. So the width represents a bounding box. We'll be looking into it in just a few seconds. So if I say 9%, 9, that means the bounding box for this string is 9. Conversion tells Java what kind of information you want to put over here. So the data intent could be string when you're using S for string. So let's get a taste for it first. So I will create a strings like so. And I put CSC 142 because it's cool. And then we run it. As we expected, it came out like that. So there are no spaces at all. And what if I told you I want to format this CSC 142 into something nicer? So I would completely remove this string here, like so. And then I'll type in what we have seen just a few seconds ago. String dot format parentheses with two parameters inside. The first being the format and the string or whatever you want to format. So let's confirm that we are looking at it right. String.format, your format, string. And now for the format, we'll be putting in quotation marks percent 9s. 9s, like so. And then we'll put in our CSC 142 that we just deleted earlier, like so. We run it now. Okay, you look at this. Oops. You can see that CSC 142 is padded to the left. It's on the right side of the string. So let's look at why. You can see that there are 9 spaces over here. 1, 2, 3, 4, 5, 6. This represents the bounding box of 9 that is dedicated to the string CSC 142. This tells Java that I want my CSC 142 to be in a box of at least of 9 spaces and nothing else like these two bars here or these two bars here should come into the bounding box that is meant for CSC 142. So let's look at a bit more. If we want to format the CSC 142 such that it's to the left with a right padding, we simply use flags. Flags are optional. You don't really have to use it if you don't want to. And we will start with negative. That causes a left justification. We'll put this negative between the percentage sign and the width, which is 9. So percent negative 9s. Like so, just a negative. And you will see that the CSC 142 string is now to the left of the box, like so. And that is how you pad your string to a particular side. And let's move on to integers now. So I'm going to put an integer now, but in order to work with an integer, we will need to use d for integers. So we will put d like so. Oops, d, and it will appear as so. And if I remove it, as you expected, the 142 will shift over here. So let's look at one more flag. When we use negative, it causes a left justification. This is completely different from a positive. This is not the opposite of the negative. It's a flag, and they are two completely different things. So a positive flag, a plus here, will cause the output to show the sign of the number. So let's just put the plus over here. You will see that there is a plus at the start of the number. This can be useful in some applications to prove that I'm not just slotting in a plus over here. I'm going to put negative in 142 to make it negative. As you can see, so I didn't put a negative here or a positive. So this basically forces the number to display its current sign, which is plus or minus. If it's zero, it'll be a plus. Okay, let's work with floats. So floats are basically something with a long decimal number like this, not 2x actually, but okay. And Java is complaining again because we are not using the correct intent, the wrong parameter. So what we have to use is f over here. So we put f, f, and then it will run with no problems. Like this. Of course, we can increase the padding to something bigger. Let's say I want it to be 18. And the bounding box will be 18 characters. Now, what if I want to cut down the number of decimal places? I don't want this 450 here. I want 3 decimal places. I will put something over here, a 0.3. This will tell Java that my float will only have 3 decimal places, and you will see it's 142.123. Like this here. If you want to use an accounting format, we just put a comma here. So let's make a larger number. And as you can see, every third number from the decimal points will have a comma. And this is very useful when you are reading really large numbers. So do take note of it. Oops. Finally, when we are using flags, we can also put a 0 over here. And that would pad our numbers with lots of zeros. So as you can see, every single space has changed to a 0. And that's about it for string formatting. Now you know the basics. Let's move on to the basics of file operations. Let's clear everything. So we're starting from scratch. So we can create, we can write, and we can read to a file. These are the 3 basic things that we'll be learning today. It's pretty simple. And before we do that, we have to import certain libraries when working with them. So some common ones are java.io, java.util, java.awt, Java Swing. But today we want to use something called java.io.filewriter. How do we import something, you may ask? So it's really simple. So just type in import java.io.filewriter like this on the very first line of your code. So all your imports must be at the top of your code. Otherwise, it doesn't really work. import Java IO file writer. So let's start to create a file. You only need one line, and this is how it's done. Excuse me. You start with text file. As a reminder, you can call this anything you want, and then we put equals new like this. So remember earlier when we have str1 and we didn't call it a string, Java is confused. So what is this? I have no idea what this is. This is a file writer. Us. New file writer. You'll notice that a lot of the times the first and the fourth words are pretty much the same. So you now need to give it a name of the file that we want to create. So I'll put pancake recipes.txt for text file. And Java is also complaining now because we need to put an exception over here to prepare. So this is what we'll do. Throws IO exception, stands for in-out exception, and then another one here in your main method. So when we run now, you'll notice that over here, a file will spawn right underneath the src, or maybe below here. And that is pretty much how to create a file. It's over here now. It's blank, pretty much. And that's about it. Okay, now let's look at how to write to a file, sorry. To write to a file, you just use text file.1 write. So as we know earlier, text file1 points to pancakerecipes.txt, but another way to put it is to say text file1 is in charge of pancakerecipes.txt. So I will tell text file, hey, I want you to do something. I put a dot here. Oops. And then I'll tell it, you ask, what do you want me to do? I want you to write. And then parentheses to tell it how to write. So what I want to do now is I want to add several lines to my pancake recipe. So let's open it sideways here so we can see it live in action. So I want to write flour, 20 tablespoons, like this, and I'll run it. You notice that nothing will actually happen. That is because I didn't close the file. So once you're done writing, we need to close the file, like so. Text file, hey, I want you to close because I'm done with you. Then that's it. Nothing, you have to put nothing over here to close the file, just leave it empty. And then when you run it, you notice something nice comes out over here. Flour, 20 tablespoons. So you can continue to write several things. So if I copy this, I paste it, I can choose butter, 10 teaspoon, and you will see that it's going to write the second line over here. Why is that so? Because we didn't use a \n. We discussed this earlier. So \n, oops, new line, like so. And you will see that it's going to go down over here. Like this. So I'm going to add a couple more lines to make sure I hammer home the point. Make sure that you add a new line for each of them, like so. You want it to look nice, something like that. So you can see that I have 5 lines, 4 for the recipe and 1 blank line because of this guy. And that is how you write to a file. So you normally write on one line, and when you want to move the next one, you use backslash n. Okay, let's learn how to read from a file. This one is a little bit more challenging, so let's try it. Today, we'll not be using file writer to read from a file. We will be using file. So file, let's give it a name, in data file, like this, data file, new file. So we need to import java.io.file. So we need to tell data file to point to something. So I want data file to point to my pancake recipe, and in essence, be in charge of my pancake recipes. I want it to handle my pancake recipes. So the moment I put my file name here, let me copy it so that we don't have typo. Oh, hang on. All right, we have to put quotation marks, right? That's how we do it. So data file now, when we run this, will point to pancake recipes, and it will essentially bring this pancake recipe into the stage right over here into your program. But that is not enough if you want to read it. If you want to read the file, when the file is already on the stage, you need something called a scanner. Scanner. Scan one. Call it as usual, call it anything you want. New scanner. So my scan one is a scanner, and it is asking me, what do you want me to start scanning? I'm going to tell it, I want you to scan data file which contains my pancake recipes.txt. So I'll just put in data file, which is the same guy over here, and that's about it. Now we can scan it. So the moment I want to scan something, I would say, hey, scan one. I know you are scanning data file now, which contains my pancake recipes.txt. So, hey, scan one, give me the next line in the file, like so. And again, you'll notice nothing really happens because although Java did read this and process this normally, you need to know that this result is not saved anywhere. It's not saved to something, it's not printed. So again, we must make sure that we do something to the data or else it is gone for good. So let's print it out. Print out. So it asks you, what do you want to print? Say, I want you to print the result of this. So I scan one, next line will be printed. So the moment I press run, you'll see the first line. Like so. Flour, 20 tablespoons. Exactly what it is in my secret recipe over here. So let's do it again. And what happens is After reading the first line, you will move on to the next line when I call it again, and then you get my second line. So to keep going, you just keep writing the same exact code, like so. And there you go. My secret pancake recipe is exposed to the world right now. And that's pretty much it for the basics of file IO. So today you have learned how to do basic formatting for strings, and you have learned the basic operations for file creation, writing, and reading. Tomorrow we'll be discussing control flow statements, so do stay tuned. My name is Aaron, and thank you for watching.